Hello. Very good morning, students. We have started the chapter Complex Number. And last day, I have discussed so many properties of the chapter Complex Number. Today, also some of the properties and so many examples. Look at the board. Heading Modulus of a complex number, the standard form a plus ib. And last day I have discussed the conjugate, the additive inverse, the multiplicative inverse. Today, the modulus of the complex number z equal to a plus ib. The modulus symbol mod of z and its direct formula square plus b square means real part whole square plus imaginary part whole square root of this. So this is the formula for this. Its geometrical representation. Also you can remember what is the geometrical representation of this. Actually, firstly I should discuss the representation of a complex number geometrically. Geometrically, you see, I have drawn the x-axis and y-axis. It is Cartesian plane. Actually, for complex number, we have to consider a plane which is called Argand plane. I repeat, Argand plane. So, what is the difference? In Cartesian coordinate, generally we write this x dash is the x-axis and y dash is the y-axis. But in Argand plane, what you will consider, or complex plane, what you will consider, the x-axis, x dash is real axis and this one y-axis is imaginary axis. Actually, all the points on x-axis are purely real part and all the points on y-axis are purely imaginary part. So, in short, you remember x-axis is the real axis, y-axis imaginary axis. Now, in Cartesian coordinates, a point is P. We consider this is x, this is y. Same thing for this plane, as I have considered this one is real axis, this one is imaginary axis. The point as Cartesian coordinate, we write this, and the point as a complex number, we can write x plus iy. You see, the difference is in Cartesian coordinate, we write this is x, this is y, that's why xy, and this point is going to denote for this Argand plane the complex number. Now, I was talking about the modulus. What is modulus? So, according to this diagram, if I draw the right angle triangle, this is x, this is y, as it is xy. So, modulus is nothing but OP is, you see, OP by Pythagoras theorem, you are getting x square plus square. If I take this one is a, this one is b, this one is a, this one is b, or this is ab, then we are getting square plus b square. So, this is the OP is the representation of the modulus z. I think it is clear. Now, the different properties of modulus. There are so many important properties of modulus. One by one, though few properties will be needed to solve the sum, and most of the properties, if you are interested, you will try to prove. In most of the books is given, though the proof is not important for the exam. So, some of the properties of modulus of complex number. Say, number one, modulus of z, modulus of minus z, and modulus of, what is this? Last day I told you, the conjugate of z, all have same result. Because this one is what? Z. Modulus z means modulus of a plus ib. So, answer already by formula I have written square plus b square. Similarly, minus z means minus a minus ib. Its modulus is root over minus square plus minus b square. Same answer. And same thing, this one you know, mod z bar equal to, this one is conjugate of z, last day I discussed, a minus ib. So j modulus of this one is also root over square plus minus b square. So all are same result. Now most important property for modulus of complex number is or are, number one, you see, very interesting property, and you can verify this one. We can also verify, though I am not going to show now, it is not so important for the exam. So only just know the property. If you are interested, you can see the proof, or one day I will discuss the proof. What? The modulus of product of two complex number. You see, product of two complex number is whole modulus. We can write as individual of their modulus, sum of their individual modulus. The first property. Similarly, I'm sorry, it is into sign. Product of two, the whole modulus of product of two complex number is equal to product of their individual modulus. This property, to do the sum, in most of the cases we will try to use, our calculation will be very simple. Not only that, for three complex number also you can use the same property like this, equal to mod of z1 into mod of z2 into mod of z3 and so on. And not only that, the same property you can use for division also, like modulus of z1 by z2 equal to mod of z1 by mod of z2. But be careful, take the note for this one, whole modulus z1 plus or minus z2 is not equals to their individual modulus plus or minus first one plus or minus second one. This is wrong, not equal to. So for into and division we can use the distributive property. Now where we will use it? Very interesting example. First we are going to consider, just follow the sum. We can do the sum by two methods. So a question is given, find the modulus of, say our question is given 2 plus I by 1 minus I. So a student is solving the sum like this. He or she is going to consider let z equal to this, and he or she is trying to make it as standard form a plus ib. So what is writing? Multiplying the conjugate both numerator and denominator. In the numerator we are getting 2 into 1 2 plus 2 into I plus I, and I into I is I square, and denominator is square minus b square. So finally we are getting 2 at I square, you know the value is minus 1, that is 1 plus 3i divided by 2. Why 2? 1 square plus minus I square value is minus 1, so minus minus plus 1, directly I have written 2. So if I write a plus ib form 1 by 2 plus I into 3 by 2. Now use the modulus formula. Therefore mod z equal to root over a square plus b square. So finally the answer is coming root over 1 by 4 plus 9 by 4, that is root over 10 by 2. The answer is coming this, but the method is a very lengthy method. Those who are using the property, what they will show, very interesting. You see, the sum is also correct, but the method is lengthy. But those who are using the property of modulus, what they are doing, try to clear. The question is given this one, we have to find the modulus of this one. So first we are putting the modulus of this, it is given in the question. Now in the numerator this is z1, this is z2. So according to the property, what the property we know, modulus z1 whole modulus z1 by z2 equal to mod of z1 by mod of z2. Using this property, what we can write? We can write mod of 2 plus I divided by mod of 1 minus I. Now, for the numerator, we have the formula of modulus root over square means 2 square plus b square. B value is 1. Similarly, for denominator, a is 1 and b is minus 1. So finally what we are getting? Root 5 by root 2. And what was the previous answer? The previous answer, if I rationalize this one by root 2, that is, you are getting root 5 into this is root 10 and root 2 into root 2 is 2. You see, we are getting the same answer. This method is shortest method. I think it is clear. Now, so I think modulus property is clear to you. One more example. Our second example, find the modulus of, say a question, and I am taking the question like this. Say it is given z1 equal to 1 minus I, z2 equal to 2 plus 3I, z2. Question is asked, find the modulus of, look at the board what I am writing, z1 into z2 bar. I think you know what is z2 bar. Last day I have discussed z2 bar is nothing but the conjugate of this. So first, as z2 is this, for answer what you will do? Modulus m. For numerator, first one z1 also same into z2 bar, as z2 is this, so z2 bar means conjugate of z2 is 2 minus 3I. Now again we are using the property, that is modulus of first into modulus of second, in bracket must write the reason as modulus z1 z2 equal to mod of z1 into mod of z2, using the property. Again use the formula, this one root over square plus b square, b is minus 1, and for second one root over square plus b square, b is this. So final answer we are getting root 2 into root 13, that is root over 26. I think it is clear. So this type of so many sums you will get in the study material. Again, one more sum I am going to discuss. Look at the board. So a question is given. Find the modulus of 3 plus I divided by 2 minus, simple question, I whole cube or whole square. The sum also we can do by two methods. What? First we will do, try to clear, but that will be lengthy method. Numerator same. If I expand this one, again denominator will come in the form of a plus ib. And then by rationalization, the full question we can make as standard form a plus ib. After making a plus ib, then we can find the modulus, but the method will be lengthy. The simple method, question is given, find the modulus of this, or as a symbol you can write let z equal to this. The question is find mod z, modulus of z equal to whole modulus. The right side is 3 plus I, and this one into as a product you can write 2 minus I, 2 minus I. Now you see there are three complex number in the numerator 1, denominator 2. So what the property we have got or we are using? Well, whole modulus for so many complex number given as a into, as a division, we can distribute the modulus. So by distribution law, what we can write? 3 plus I divided by modulus 2 minus I, modulus into modulus 2 minus I. That is, this formula root over square plus b square. Square means 3 square and b is 1 square. This one is also same, 2 square plus minus I is minus 1 square means directly I am writing 1 square. This one is also same. So finally what we are getting, root over 10 divided by root over 5 and root over 5. Finally root 10 by 5 is the answer. Very simple. So using the properties of modulus you can do it. That will be very simple. Now another question. So I think modulus clear to you. One more thing I want to discuss.